Hello, in this video I want to talk about the effects of vertical changes to the graph y equals tangent x. And if I go ahead and put in all the coefficients into your tangent equation, we are talking about A, which affects the stretching from the horizontal axis, and then K, which involves translation or just shifting where you don't change the shape of the graph in any way, you just move it up or down from the horizontal axis. All right, so that's what we're going to look at. I want to just remind you about the basic shape of tangent. So here's what I would have in my mind, and probably a little more. I would know this basic shape, and then I would know that it has asymptotes, and then I'm probably going to go ahead and, this is an anchor point that's pretty easy, 0, 0. So that's when the angle is 0 radians, the ratio y to x, which is what the definition of tangent, is also 0. So what I do when I'm doing this, I go ahead and say, all right, where are my asymptotes? Since I know the definition of tangent is y over x, then it's wherever x is 0. And if I look at the unit circle, where is it that x, right, this kind of motion is 0? It's right here. So it's here at pi over 2. And you can either say negative pi over 2 or 3 pi over 2. But since we're on an axis and we're going to draw this way, we're going from left to right, it makes sense to go from negative pi over 2, then pi over 2, then to 3 pi over 2, and so on, as you're basically going around the circle, putting your angles in. So what I would do then is I would say over here at negative pi over 2, and then kind of go the same distance out here, pi over 2. I would draw in my asymptotes, right? And again, how do I know? Remember, this is 0, 1. This has coordinates 0, negative 1. And of course, when I put 1 divided by 0 or negative 1 divided by 0, I'm going to get asymptotes. Okay. Now, I know I have this point here, and I'm basically going to snake through here. But remember, these values here, which happen to be pi over 4, and negative pi over 4, and pi over 4, they are kind of easy points to remember also. So I want to kind of go over that. So remember, when you're working with tangent, even though it's written y equals tangent x, really the x is just a placeholder. I could have written it tangent of just a box waiting for an input. What's the input? Well, the input to a trigonometric function is always an angle. So the output is the ratio, and you just have to remember how that ratio is defined in terms of, for tangent, it's y coordinate over x coordinate of the associated angle. So here, when you look at the unit circle, if you look at pi over 4, you have coordinates square root 2 over 2 and square root 2 over 2. So when the input's pi over 4, you take the tangent of pi over 4, which is y over x, and you'll get 1. And if your input is negative pi over 4, then tangent of negative pi over 4, you're looking at the coordinates y divided by x, and that will be negative 1. So really then, when I come back here and I say, all right, let's go ahead and fill this in, I would say negative pi over 4, and then down 1. So this is the point negative pi over 4, negative 1. And then over here, I'd go pi over 4 up 1. So I'd have pi over 4, 1. And here I am going to draw this now in. And the graph hugs the asymptotes coming out here. And the period, since this is one basic shape, we would say end minus beginning. So pi over 2 minus a negative pi over 2. The period is pi. All right, so that's your basic shape, and this is what you'd have to keep in mind all the time. This would be in the background, and you've already memorized it. So let's just take a look at some of the effects, and we'll look at specific examples. But B and C affect the horizontal changes. A and K affect vertical changes. So if K is positive, the tangent graph is moved just straight up from the y equal K axis. I'm sorry, from the normal y equals 0. So it's just moved straight up if K is positive, and it's moved straight down if K is negative. And from what? From the regular axis, which in this case was this horizontal axis, and that's y equals 0. So it's the x-axis, but the actual equation is y equals 0. Right? So this is y equal 1, y equal 2, y equal 3, that kind of thing. And then the A, as long as the A is bigger than 1, and it can be positive or negative, the tangent is going to be more narrow than the regular basic shape of the tangent. And of course, if A is negative, it's going to be reflected over the y equal k axis. And if a is a fraction, again, positive or negative, obviously if it's negative, it's just going to get reflected in addition to the widening effect. But if a is a fraction, then the tangent's going to be wider than the basic tangent graph. So now let's take a look at some specific examples. Here, if I look at y equals tangent x plus 4, I've gone ahead and rewritten all the a, b, c, and k coefficients. This is your new horizontal axis. That's going to tell me what the tangent is going to wrap around, if you will. So what that means is, whereas it used to be y equals 0, now it's here, y equals 4. Okay. And this is, there are no horizontal changes, so my x equals 0 is still going to be the vertical axis. Now, since I know the basic shape, I know I'm going to have the graph coming in through here. There are no horizontal changes, so my asymptotes are still at negative pi over 2 and pi over 2. The only difference is when I put in negative pi over 4 and pi over 4, what do I get? So remember, it's this basic shape, but it's going to be what? The whole thing is going to be moved up 4. So when I put in negative pi over 4 right, into tangent x, I have negative 1. And so then I have negative 1 plus 4 will give me 3. And when I put in 0, tangent of 0 is 0, so then I'll have 0 plus the 4 is 4. When I put in pi over 4, tangent of pi over 4 is 1, and then I add 4, I get 5. So you can do it that way by chart, or you could say, hey, I know the basic shape, this is my basic shape, and I'm just going to see what happens. The whole thing moves up 4 from this axis, so let's take a look at it. So now I have a new axis, and whereas before what I would do is I would go from the origin, I would go over pi over 4 and then up 1, and then I would also go negative pi over 4 and then down 1, and then go ahead and draw it between the asymptotes. I'm going to do the same thing here. Here's my new axis. I'm going to go over pi over 4 and up 1. I'm going to go to the left pi over 4 and down 1. And then here's my asymptotes, so I'm going to draw this like that. Okay. So that would make this point 0, 4. That would make this point pi over 4, 5. And that would make this point negative pi over 4, 3. Okay. So that's how you graph this one. Let's go ahead and graph something where you have a shift that's going down. So let's take a look at y equals tangent x minus 6. And again, I've put in a, b, c, and k. So again, you can see that there's no horizontal changes because b is 1 and c is 0. So I have the same asymptotes here, negative pi over 2 and pi over 2, and the vertical axis is x equals 0. But now the whole graph is shifted down 6. So my new y-axis, so to speak, is y equals negative 6, right? And then I can see from here, since I know in my basic shape, I basically know the asymptotes. I need 5 pieces of information and this basic shape. I need the 2 asymptotes, the negative pi over 4, the pi over 4 values, and then 0. As long as I keep this in mind, it's a lot easier to graph. So I'm going to go, normally I just basically go negative pi over 4 and down 1, but I do that from here. Now I have a new axis, so this is my new origin, if you will. I go over negative pi over 4 and I go down 1 here. I go over pi over 4 and I go up 1. Okay? So this is negative pi over 4 and pi over 4. And this point is negative pi over 4, negative 7. This one is pi over 4, and then, I'm sorry, yes, that's right, pi over 4, and then negative 5, right? So you draw this in, sorry, like that, okay? And this corresponds, you can count 1, 2, 3, 4, 5, so there's your negative 5. And you can check that for negative 7. So that's your basic y equals tangent x minus 6. Let's take a look at this example. Y equals negative tangent x plus 2. So we could see that you're moving the entire graph up 2, but you're also reflecting it over the new horizontal axis. So what we have then here is, again, if you plug in your values, and you can either plug in your values or you can move from the new origin, that's up to you. But I would draw in here the plus 2, right? So this is y equals 2. Okay. And I still have, I have no horizontal changes, so b is 1, c is 0, so my asymptotes are still negative pi over 2 and pi over 2, right? I know I'm going to come in through here, right? And somewhere here at negative pi over 4 and then pi over 4, something's going to happen. So what's going to happen? Well, technically, normally what I would do if I were just looking at the effect of the 2, I would move over pi over 4 and up 1. But now it gets reflected, so I go over pi over 4, but I go down 1. So I'm here. And then normally I would go negative pi over 4 down 1, but now I'm going to go negative pi over 4 and up 1 because I'm multiplying by that negative 1. And so you can see here, if you actually plug in the values, when I plug in negative pi over 4, I get negative 1 here, but then I multiply it by negative 1, so I have two negatives that multiply and become a positive. I have 1 plus 2 is 3. So you can check these values. So essentially what I now have is this. Okay. So the idea is what used to be like this, what was above, now became reflected and became below. So let's see if I can kind of... Okay, so it used to be that if you just had the plus 2, right? You'd do something like, oh, probably go through here. Something like that. And then it would be, let's see over here. Right. But what was above now got reflected and became below. See? So you have this reflected here. You have this reflected here. So now what you have are these points here at negative pi over 4, 3. And here you have pi over 4, 1. And this is 0, 2. So your graph is this one here. Okay. Now let's take a look at the effect of A when it's actually a number, not just negative. So let's take a look at y equals 3 tangent x. So again, B is 1. I'm going to put that in here. All right. So B and C are just like they are for the regular tangent curve, the basic shape. So you still only have a vertical change. So you have your asymptotes at negative pi over 2 and pi over 2. And the idea is you still want to evaluate here at these values, negative pi over 4 and pi over 4. I call them kind of like anchor points because you know what the basic shape is at that. So then when you plug in negative pi over 4, tangent of x is negative 1. So you're saying 3 times negative 1, which is negative 3. So what happens is from this point of origin, because remember this, the horizontal axis is still y equals 0. You would normally go over pi over 4 and down 1, but now it's that effect is being multiplied or amplified, if you will, by 3 times. So you're going to go over, and then you're going to go, instead of going down 1, you're going to go 1, 2, 3. So you're going to be here. So this is going to be negative pi over 4, negative 3. And then normally you would go, for the basic shape, you would just go over pi over 4 in the x direction and up 1, but now you're going to go 3 times as much. So you're going to go over 1 and up 1, 2, 3. So you're going to be here. Okay. So notice then that this is a little bit more narrow, right? Because normally you would have been here and here. You would have been, the regular pi tangent would have been more like this. Right? But it's a little bit more narrow because your input is being multiplied and amplified in its effect. So the idea is for the same amount of input you're going up a lot more, okay, or down a lot more. All right, and let's take a look at what happens when A is a fraction. All right, so again, we have no horizontal changes, so your asymptotes are still at negative pi over 2 and pi over 2. And you're still going to go here through the anchor point if you will, over 0, 0. But now what happens is when you put in your familiar anchor values, negative pi over 4, you know the tangent of negative pi over 4 is negative 1. But now it gets multiplied by half. So what happens is normally, if I'm here at pi over 4 and here at negative pi over 4, I would go negative pi over 4 and I would be down here at negative 1. But now I'm only at a half here. And then I normally would go over pi over 4 and up 1, but I'm only going to go up half as much. So now when I graph this, it's going to be a lot wider. Right. Okay. Because regular tangent, the basic shape would have been here and here, so it would have been a little bit more narrow, right? That would be regular tangent. All right, thank you so much for listening.